Good morning, chemistry students. Here are your Chapter 14, Day 2 notes. We're going to be starting at number 2, and we're going to go through the end of Chapter 14, Section 1. So remember that yesterday we talked about the noble gases, and the characteristic that was true of the noble gases is that their highest occupied energy level, S and P sublevels, were completely full of electrons, which is what makes them particularly stable, and they typically don't form compounds and get involved in chemical reactions. So continuing to talk about our elements according to their electron configurations, next we're going to talk about the representative elements. These are the elements in groups 1A through 7A. So I'll put a periodic table in here really quick to kind of show you where we're talking about. Okay, so again, what we're talking about here are our tall columns of the periodic table. These are our representative elements. These are the ones that we talked about yesterday, which were our noble gases. Okay, so we're talking about the tall columns of the periodic table right now. The representative elements display a wide range of physical and chemical properties. Remember back in Chapter 5 we talked about the metals being to the left and below that heavy stair-step line on our periodic table, and our nonmetals being to the right and above that heavy stair-step line of our periodic table. So when we're talking about these elements in these tall columns of the periodic table, some of these are metals, some of them are nonmetals, and some of them are metalloids. Oops, misspelled that. There we go. And kind of the characteristic that all of the representative elements are going to have in common is that their S and P sublevels of the highest occupied energy level. And again, we're going to write that a lot today, so we're going to start to abbreviate it HOEL, okay, are not filled. So the elements in groups 1A through 7A, their S and their P sublevels are not going to be completely filled. So again, we want to kind of look at some specific configurations. So we want to look at the group 1A elements electron configurations. So again, I'd like you to write the electron configuration for lithium, for sodium, and for potassium. And again, what I'd really like you to do is pause the video for a moment and go ahead and use your periodic table to write your electron configurations for these three elements right now. For lithium, remember we always start at our top left-hand corner, so we have our 1s2, and then we have our 2s1. For sodium, 1s2, 2s2, that takes us to beryllium, 2p6, that takes us to neon, and then sodium is 3s1. For potassium, 1s2, 2s2, 2p6, 3s2, 3p6, that takes us to argon, so potassium has a 4s1. So again, what we kind of want to notice is we want to notice about our highest occupied energy level, so that's our highest number. So again, I'm just going to underline that part of our electron configuration for all three of these, right? And what we notice is they have quite a bit in common. They're always S1. So what all of the group 1A elements electron configurations have in common is that there is only one electron in the highest occupied energy level, and it's always our number S1. So now I'd like you to do the electron configuration for the group 4A elements electron configurations. Specifically, I'd like you to do carbon, silicon, and germanium. So again, the best thing for you to do is to go ahead and pause the video at this point, get out your periodic table, go ahead and write that out. So for carbon, which is atomic number 6, so it has 6 electrons, so we have 1s2, 2s2, 2p2. For silicon, which has 14 electrons, 1s2, 2s2, 2p6, 3s2, 3p2. And for germanium, which has 32 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, that takes us to argon, 4s2, 3d10, 4p2. So again, we're going to do the same thing that we've done before. We want to specifically look at that highest occupied energy level. So I'm going to underline the portion of the electron configuration that is the highest occupied energy level. And remember, technically the 3d10s are part of the third energy level, so they technically are not in the highest occupied energy level. And again, what we're looking for here is we're looking for what do all of these electron configurations of the elements in the same group or family or column of the periodic table have in common. And what we see here is that all of these elements have 4 electrons in their highest occupied energy level. And every single time it's number S2, number P2. So what I want you to kind of notice and also think back to about what we talked about yesterday. The noble gases are in group 8A, and they had 8 electrons total, okay? 2 in their S's and 6 in their P's. 8 electrons total in their highest occupied energy level. So they were group 8A, and they had 8 electrons in their highest occupied energy level. Group 1A has 1 electron in its highest occupied energy level. Group 4A has 4 electrons in its highest occupied energy level. Well, this is why a periodic table with those A and B marks is much nicer than one that's just labeled from 1 to 18. right? Group 1A has 1 electron at its highest occupied energy level. Group 4A has 4 electrons at its highest occupied energy level. Group 8A, the noble gases, have 8 electrons in their highest occupied energy level. So, how many electrons do you think Group 2A has at its highest occupied energy level? I hope you said 2. How about 3A? 3. How about 5A? 5. How about 6A? 6, right? I hope you're seeing the pattern here. So the pattern is that for any representative element, and again, remember, a representative element means we're talking about an element that's in a tall column of the periodic table. Its group number equals the number of electrons in the highest occupied energy level. We're going to use that information when we start to talk about whether an element forms an ionic bond or a covalent bond. Okay, so Group 1A has 1 electron in its highest occupied energy level. Group 2A has 2 electrons in its highest occupied energy level. Group 3A has 3 electrons in its highest occupied energy level. Group 4A has 4 electrons in its highest occupied energy level. Group 5A has 5 electrons in its highest occupied energy level. Group 6A has 6 electrons in its highest occupied energy level. Group 7A has 7 electrons in its highest occupied energy level. And Group 8A has 8 electrons in its highest occupied energy level. Group 8A, remember, are our noble gases that we talked about yesterday. So we also notice on our periodic table that the short columns also have B's behind them. Okay, so in the periodic table, the group B elements separate the A groups on the left side of the table from the A groups on the right side. So basically all I'm saying here is the B groups, which are the short columns of the periodic table, they're stuck in between the tall groups. The elements in the B groups are referred to as the transition elements. I might have spelled transition wrong. Transition elements. They're going to be our last 2 groups. So technically there are 2 types of transition elements. Number 3 are just kind of called straight up the transition elements. These are the group B elements that are usually depicted or displayed, we'll use displayed, sorry, in the main body of a periodic table. So again, what we're talking about here are those short columns. So we're kind of talking about the B short columns. They're also kind of sometimes labeled groups 3 through 12. And what these elements have in common is that they're highest occupied S sublevel and a nearby, and nearby we mean nearby in terms of energy, D sublevel contain electrons. So kind of what's really important, or the big characteristic of transition elements, is that they are characterized by the presence of electrons in d orbitals. The other type of group B elements are called the inner transition elements. These are the elements that appear below the main body of the periodic table. So these are the two rows that are pulled out of periods 6 and 7 and typically placed underneath the main body of the periodic table. In these elements, the highest occupied S sublevel and a nearby, and again nearby in terms of energy, F sublevel, generally contain electrons. So another way to say that is that the inner transition metals are characterized by the presence of electrons in F orbitals. So the periodic table can be divided into sections or blocks that correspond to the sublevels that are filled with electrons. We've talked about this multiple times already, right? We have our S block, which contains the elements, contains the elements in groups 1 1A and 2A, and the noble gas, helium. Even though helium's typically put in group 8A, it just as well could fit in group 2A. The P block, which contains the elements in groups 3A, 4A, 5A, 6A, 7A, and 8A, with the exception, so except or not basically, helium. Because helium only has 2 electrons in its highest occupied energy level. We have the D block, which are our transition metals or transition elements. Those, remember, are our short columns on our periodic table. And our F block, which are our inner transition metals or elements. Remember, when we're talking about our periodic table this way, each period on the periodic table corresponds to a principal energy level. So again, remember, those are the N numbers that run down the left-hand side of your periodic table. And your principal energy level is the same as the row you're in on your periodic table, for the most part. For the transition elements, the electrons are added to a D sublevel with a principal energy level that is 1 less than the period number. So again, basically what we're reminding you of here is that, remember, the D sublevels are 1 behind whatever period we're in. So the first Ds we come to are in the 4th period. Those are 3 Ds. For the inner transition elements, remember, those are the 2 that are rows that are pulled out and underneath the periodic table. The principal quantum number or energy level of the F sublevel is 2 less than the period number. So again, remember, the top set of elements that's pulled out and underneath your periodic table, technically that top row fits in period 6. But because the F's are 2 behind, those are 4 F's. And that brings us to the end of Chapter 14, Section 1. Your homework is on page 396 to answer questions 3 through 5. Have a good day. I'll talk to you tomorrow.